Okay, it is circle time. So the radius of the circle starts at the center of the circle and goes to one of the edges. So we have PB, PI, or PG. Now, P does not have to be the first letter. PB is also the radius, IP is also the radius, and GP is all the radius. So there are 6 possible answers here. There's also a hidden 5th one. Even though it wasn't drawn, PE would work. I just wouldn't accept it. The diameter of a circle goes through the circle and goes through the center of the circle. So for the answer for this one is BG, also GB. Now it looks like IE could be one if you continue the line, but remember, pictures lie. We don't know actually where E is, and if we don't know where E is, we cannot assume where E is. We name a circle by naming it by its center, so circle P. But we can also name a circle by its center and a point on its circumference. So PI, PB, PG, PE are all acceptable answers. But the center of the circle must always be the first letter. You cannot flip them. Name a chord. A chord is a line segment that connects 2 parts of the circle together. The easy answer here is GE, or EG if you want. But by the definition of chord, GB is also one. Even though it is the diameter of the circle is a chord because it connects 2 parts of the circle together. For problem number 2, we need to find the circumference, and we're given the diameter. The formula for that is diameter times pi, so 28 times pi. The problem says you can have a rounded answer. If you plug that into the calculator, you'll get 87.92. If you use pi as 3.14, you will not have to worry about it doing any rounding whatsoever because it will come out to a nice number. To find the diameter, what I'm going to do is take the 54 radius and divide it by pi, which is approximately 17.2. And I put that answer into the diameter. Notice that there is no exact answer requirement here because the exact answer would be 54 divided by pi, which looks silly. To find the radius, I'm going to take 54 and divide it by 2 pi, which is approximately 8.60. Since it's the radius, I wrote it down there. Now, interesting point. Because I'm dividing by 3.14, it is possible that through rounding, the diameter will not be exactly half the radius. So calculate it individually each time when you find it. This is probably something that you learned through your McGraw-Hill lessons and screaming, why doesn't this work? For many of these naming problems, there are more than one answer. I'm just going to give one and explain how you can get others. For a major arc, we need an arc that is over 180 degrees. So I picked MQ because it's a line that goes through half the circle. And then I just went a little farther to A. For a major arc, you need 3 things: beginning, an end, and a point in the middle. So I started at M, I picked a point in the middle, I picked O, I could have picked S, I could have picked Q, doesn't matter, and then I picked A, the point it ended at. For a minor arc, I need something below 180 degrees. To be certain, I'm going to pick something that is less than half a circle. So, using the line MQ again, I'm just going to go over a little bit. Now, I picked QA and AJ. I didn't have to, but my reason for it was when the name comes up in just a second. Minor circles only have a beginning and end. The 3rd point on the major arc is what tells you it's a major arc. If you only have a beginning and end, you're supposed to go the shortest way there. So JQ is the shortest path, which leads through A, but doesn't include A in its name. Well, I've kept on talking about half circles, so I'm going to use the one I've been using all the time, MQ. Now, I had 2 choices here. I could go through M, J, A, Q, or I could go the other way, but I just picked this one. Since I went through J, I included in the name MJQ. The naming scheme for a semicircle is identical to the naming scheme for a major arc. You need 3 letters. The measure of angle SXO is 90 degrees because if you look in the corner there is a box, and that box represents 90 degrees. The measure of RQS is located on the circle. It says 70 degrees. So the section purple is marked 70 degrees. Measure of arc OQ. Now notice that it only has 2 letters, which means we are going the short route. We know the measure of angle QS, which is 70 degrees. We know the measure of the arc OS, which is 90 degrees. We add them together, and we get 160. To find the measure of arc MOA, we need to put down the arcs that we do know. The first arc we know is 70 degrees, QS. The other one we know is OS, which is 90. The measure of arc MOQ is 180 degrees, so if we take the 90 and the 70, what is left is 20 degrees. But you might be asking, why did we find that 20 degrees? To find the last arc, AQ, we notice that it is a vertical angle with MO, which means it is also 20 degrees. So now we just add up all the arcs. 20, 70, 90, 20. That gives us 200 degrees. Just double check. 3 letters means 180 or bigger. 200 is bigger than 180. We're supposed to find the measurement of arc MOA. We know the radius is 12. We know that the angle we're looking at is 200 degrees. We know that is because we're stealing it from above, where it says measure of arc MOA is 200 degrees. To find the length of the arc, we're going to find the circumference of the circle, 2 pi r, and we're going to multiply it by the percentage of the circle that is being measured, which is theta divided by 360. 2 times 3.14 times 12 times 200, all divided by 360. And that gives us 41.87. Pay close attention. There are a couple things that just need to be altered slightly. Notice the diameter cutting the chord perpendicularly. That means that the 55 degrees on one side is matched by 55 degrees on the other side. It's one of the theorems. Notice the line TZ is equal to the line DZ. That means they have the same arc measurement, which means 100 degrees. Notice that RU cuts the circle in half. That means the arc measurement for that would be 180. Well, we know 55, we know 100, which means there's 25 left. Using the same logic, there's 25 left on the other side. Arc ZV is a minor arc, which means it has to be under 180 degrees. If we trace the path, we have 55 and 55. 110 is less than 180, which means that is the final answer. We look for arc SD, and we run into an ever so slight problem. It says SD, it means RD, so that's 25 degrees. Arc ZZ would be funny because, well, it'd be 0. But I believe it is TZ, which happens to be a little bit different. TZ is 100 degrees because that is how far it is. It's a minor arc, so we don't have to worry about it being over 180 degrees. Now let's clear those numbers so it's easier to see what we're doing. We got ZV is 144 degrees, and because, as we just discussed before, the diameter is cutting across and it cuts it at a 90-degree angle, that means that chord is cut into 2 even pieces, so 72 and 72. So FV in that case is 72. So SU is really RU, and so that's why I changed it there. It goes across. That means that LU, the shorter distance, is 150 divided by 2 equals 75. Now, you may notice that I just bothered to change it to RU there because I went, oh, well, that'll be an easy fix, never knowing until later that I could have made that change earlier with the SD one above instead of just mention it. Well, I'd already restarted this video for a bit, so I wasn't going to go back to fix it for one letter. So hopefully that doesn't bother you. Now we're looking for FL. FL is part of a right triangle. You don't see it because the LZ is not marked, but FL squared plus Z squared equals 75 squared. You may be wondering where I got this 75 from. Well, turns out that LZ is a radius of a circle, which means it is 75. 75 squared minus 72 squared is 441. The square root of 441 is 21. And that means FL is 21. Since we know FL is 21, we marked it on the circle. Turns out that LU minus LF gives us UF. So we have 75 minus 21 equals 54, which means that UF is 54. An important side note here is you might be thinking, hey, none of those measurements match up. Well, if you don't remember, pictures lie. We're using the mathematical numbers. If it was 21, that means that F would be closer to L, which would then increase the distance of UF. Section 10.4, let's play with some circles. CK is a minor arc, which is 40 degrees. CNK is a major arc, which is going to be 360 degrees minus that small 40 for 320. NC is a minor arc. It's connected to the inscribed angle NHC, which is 56. When it is pushed out to the outside of the circle, it is doubled to 112. We're going to borrow that 112 from before. NK is a minor arc. We know that because it has to be less than 180 degrees. If it wasn't, it would have 3 letters. So we have 112 plus 40, which is 152. And just to clarify, if that had added up to be more than 180 degrees, we'd have just taken it, subtracted it from 360, and find the actual minor arc. Remember, pictures lie. A common tangent is a line that is tangent to more than one circle. That means the line will only touch the circle once and only once. So in this case, it's going where the 2 circles touch. Well, if they only touch once, that means we can put a common tangent line through them. On the bottom there, it looks like I can make another common tangent line. And let's put a common tangent line on the top. Well, can we find any others? Well, no. The top one and the bottom one are guaranteed. We can't put one that touches the top and the bottom at the same time because it is blocked by the circles through the center line. For part B, we try to draw a tangent line and we run into a small problem. Because the one circle is inside the other circle, no matter what line we draw for the first circle, it's going to cross the other circle twice. Now we're looking to prove that AB is tangent to circle C. Just for clarification, 13 goes from C all the way to B. For angle A to be a right angle, we need to have a right triangle formed, which means 5 squared plus 12 squared needs to equal 13 squared. In case we didn't notice, there was a Pythagorean triplet. 5 squared is 25, 12 squared is 144, 13 squared is 169. 25 plus 144 is 169, and it turns out 169 is equal to 169. So a squared plus b squared equals c squared only works for right triangles. So if it's a right triangle, that means we have a tangent line, and if we have a tangent line, that means it is a tangent. Section 10.6 is pretty easy and pretty easy to screw up. So let's get started. Notice that angle X is located inside the circle. So we're going to take 78 and 24, add them together, and divide by 2. That'd be 102 divided by 2, which is a nice round 51 degrees. Notice that Y is outside the circle. That means it's going to be a smaller angle, so we're going to subtract the 2 angles. 69 minus 41 divided by 2. That's 28 divided by 2. And that gives us a 14 degrees. Notice as it's getting smaller and smaller, the angle is getting smaller and smaller. 69, 41, 14. On the other circle, the angle should be in between the two. 78 and 24, it should be in between the two. Try to use that to help remember which formula to use. This part of the test feels like free points. Let's get started. Let's move the radiuses over first. It is whatever it's equal to the square root of it. So the square root of 9 squared, 9. Square root of 49, 7. Square root of 8, I'm going to call the square root of 8. We're going to try to figure out what is subtracted from the x's so we can find the x value of the center. So x plus 9, when we remove it out of the parentheses, becomes negative 9. When there's nothing there at all, we call that 0. And x minus 7 is positive 7. Now let's do the same thing for the y's. When we pull the negative 9 out, it becomes 9. If there's nothing there, it's 0. When it's negative 8 and we pull it out, it's 8. Now, to find the equation of the circle, first we're going to write the bare bones of the equation. So we have parentheses, x minus something squared plus y minus something squared equals something squared. The x is negative 10, so when it goes into the parentheses, the negative sign cancels out the minus sign, making it positive 10. Same thing happens with the negative 9 for the y. The trick here, it says diameter. Diameter is not the radius, so find the radius, it is 8 divided by 2, which is 4. And now that we know the radius, we can put it in for the equals 4 squared. If 10.7 was the easiest section, 10.8, not as much. First, we notice the directrix is based off of y, so we're going to need two y numbers, the 9 and the negative 1. Since we are looking for the vertex, we need to know what the x value is going to be. Well, the x value for the vertex will be the same as the x value for the focus because we are dealing with a directrix that is y, not x. To find the vertex, we need to know the halfway point between the focus and the directrix. Well, the focus is at 9 and the directrix is at negative 1. Add them together, divide by 2. That's 8 divided by 2, which is 4. So our vertex is 0, 4. So our parabola will go in the direction from the directrix to the focus. Well, the directrix is negative 1, the focus is 9, which means our parabola is opening up. For our parabolic equation, we need the value of p. The value of p is the distance from the vertex to the focus, or the opposite value of the value from the vertex to the directrix. So 9 minus 4 is 5, or 4 minus negative 1 is 5. So our p is 5. We know it's going to be positive because it's opening up. If it was opening down, it would be negative. We're dealing with a parabola that is going up and is based off of y. So y equals 1 over 4p of x minus h squared plus k, where p is the distance from the focus to the vertex, and h is the x value of the vertex, and k is the y value of the vertex. I plug in the values. 4 times 5 is 20. H is 0 and K is 4. And I'd probably just leave it here. That way I don't screw up when I try to simplify things.